Without further ado, I am thrilled to introduce Jean-Baptiste Huynh, who's one of the people who's out there working in the educational game space, who are building games that actually look like games. We've been talking about it in the space with some colleagues for quite some time, that we need more games that look like this if we're going to push change and educational achievement. We need games that actually feel like games, and Jean has created some very graceful games for us that he's going to give us an introduction to them today. Thank you. Please welcome Jean-Baptiste.
Thank you. Thank you. I don't know if it's me who found this title. I guess not. Maybe it's you, Math. Redesigning the math experience, lessons from DragonBox. So, redesigning the math experience. That's the title. Why do we want to do that? And I need to start with that because my son, one of my sons, 14 years old, last time he came, it was in the kitchen, and he said, "Daddy, why are you doing what you do?" When you get that kind of question from your son, you have to think twice, maybe 3 times. I'm working really hard to make this happen. And I said, well, my son, why do I do that? Yeah, I guess I want all kids to learn math more rapidly, much faster. And he paused and looked at me and said, there is no, actually, it's a job for nothing. Because if you're successful and kids can learn faster math, anyway, the game of school will change so that the requirements for kids, you see my point? They will be higher. It will be always inflation about what we require for kids to enter the best universities. But then the question is, will the universities as we know them today will change this? I don't know. But I had to think twice, really. But I cannot but designing the games and the experiences where I'm making. So I'm going to keep on doing that. Although my kid is really skeptical, which is a bit weird. I guess maybe you want me to be more home. Basically, yeah, it's a beautiful picture received from a foundation. They are using one of our games in South Africa. I do the games also to get this, more of this. I was a teacher for a couple of years. Before that, I was working in finance as a stock portfolio manager. As a teacher, it's very seldom, especially in high school, that kind of, yes, natural way to say, I mastered that. It was a little bit difficult, but I got it. And maybe you experience that kind of feeling from time to time in your work. A difficult task, and then, yes. And basically, that's what I want kids to get as a feeling, and every day. Basically, when they start learning something, it should be, yes, I can manage that, and they are empowered by what they've learned. This is the big motivation. So I've spent the last 8 years of my life trying to increase the productivity of math teaching. And from teaching, I'm more into learning now, because the role of the teacher is changing, in my head at least. So let's say we want to redesign the way we teach math or learn math. So what do we need to change? So these are the usual challenges in a classroom. Problems of motivation. Difficult subjects, meaning here we are talking about pedagogy. Even if you have a kid really engaged and you have a kid who really wants to learn something, sometimes it's really hard to learn it. And it's not because the subject is really hard, I think. And here it's very normative, that's my view on the subject. I think it's because we have used too little time to design a way to communicate the subject properly. So it's about pedagogy, it's about representations. I will come back later to that. The communication barrier. As a teacher, like what I'm doing now. I'm talking. We talk too much in school, and kids are not active enough. And sometimes you want to communicate a big idea, and you don't have the tools to do it. And the language we use, especially the oral language, is pretty bad, actually. And because of the short memory and other stuff that I don't know of, but I have the intuition that it's not effective at all. The more you talk, the less people understand, usually, in a classroom. You have the time constraints in a classroom, and you have one teacher, usually, and 30 kids. And now you are a big loser. You want to communicate something, it's really not good at all, especially in math. Maybe I did not mention something very important, is the fact that usually when we learn, we need feedback. And in the classroom, very little feedback. You can make the calculation. If you spend 2 minutes to give a feedback to a student, you're going to spend your time doing feedback and never teach anything, actually. If we want to change things as well, I think it's important to understand the difference between learning, practice, and assessment. Especially in my work, people don't know the difference. When they buy an educational app or solution, they are served with a quiz. Adaptive quiz maybe, but still quiz. You can learn from quiz maybe a little bit. You might be motivated by it, but there is no real learning component in it. So assessment, the assessment industry is $1 billion industry. The practice industry maybe less. And the learning industry really per se, today that's teachers, books, and tutoring. We don't have any tools really to learn or teach better that are really designed from a very sound pedagogically viewpoint. So I wanted really to make a point here. Learning is not done by anyone almost. Might be provoking, you might consider I'm crazy, but my experience is that nobody is doing research and development in this field. And it's a pity in a knowledge society. It's a little bit weird, actually, very weird. So how can we change that? So we know the challenges, and the only way we can change that is really to understand how kids get motivated and how they learn. How do we do that? And I guess it's only one way to do it. You have to put yourself at the same level as kids. You have to listen to your customers. And already there, although many teachers understand this, usually teachers don't have the time to observe. They don't have the time to reflect, and they don't have the means to act upon the reflection they might have. Okay? So the process to change things, it takes time and energy, but that's the only solution if you want to change this educational landscape and get really good tools. So when I was a teacher, I tried many things. I had actually a partner, and we designed a couple of solutions, IT solutions. I tested many solutions. At the beginning, it was pretty teacher-centered. I needed tools, administrative tools to gain time. But at the end of the day, really, it was very clear that a big part of the solutions are video games, or they were video games at the time. It was really very simple, very clear. So why? I don't say it's the only solution, it's just part of the solution, and we have not invested enough in this solution. So why it might work, and why I do believe we can change dramatically the effectiveness of teaching and learning mathematics. Well, through games you can create a context that motivates kids. It's about the context. Some kids are motivated by the context of school, grades, and it works. It's okay in a social context. It might work. There are many ways to get motivated to do well in school and to learn. The beauty with video games is that you can create something really out of the blue almost, that's going to motivate the majority of kids. What I do love with video games, and I have to say, I'm not a gamer myself. It's just I'm a game designer by accident. It's because I want to teach more effectively, and therefore I need to do what it takes to do it. So I have to design games, right? In video games, you can create digital manipulatives. So what are manipulatives? That's objects, physical generally, that you can use in school to manipulate stuff and get an intuition, a body intuition of what the concepts are. In a video game, you can do that in a digital version, and you can add all the feedbacks you want. So if I would recommend or give an advice to people who want to get into this industry, the first thing I think you have to do is to create these digital manipulatives. And it's not only in mathematics, actually. I think it's for everything. You want to manipulate stuff. It's the most intuitive way to learn stuff. So it's very normative again. I think we learn by metaphors. At the beginning, it's physical metaphors, and then metaphors on metaphors. But for the basic learning stuff, physical metaphors are good, or digital metaphors. Autonomy, you get that, of course, in a video game. You can advance at your own pace. Time on task high if you have the subject in the gameplay. And that's the reason why it was very important to me to create an experience where whatever you do is manipulating these digital manipulatives, actually math concepts. So whatever you do, as soon as you play, you're actually playing with math concepts. So your time on task is super, super high. And in school, it's super, super low. And that's the reason why I say we can really change the efficacy of teaching and learning. And it's an individual experience, so much more effective when you can experience stuff yourself and create your own understanding. So when I realized that video games were part of the solution, so it was purely theoretical there, right? I gathered a couple of people I thought would be interested in this mission to create video games, learning video games. And we had a brainstorming session. And here are the constraints I used. So I've been very influenced by two people, Betty Edwards and Tim Galloway. Betty Edwards has written this book. She wrote this book about drawing on the right side of the brain. And she devised the methodology to learn to draw things in, I think, a week. And Tim Galloway devised a solution to teach anyone to play tennis in 20 minutes. So I discovered these two guys on the page of Research Viewpoint Institute that was created by Alan Kay. And it resonated a lot, what I've read. They wrote two books, so Betty Edwards and Tim Galloway. The Inner Game of Tennis, that's the name of the book, the title of the book of Tim Galloway. And they approached pedagogy, or they had the same problem as I had, actually, or I had the same problem as they had. The more they talked, the less people understood what they were meant to learn. So they had really to question their roles. And to some extent, they understood that they were kind of a barrier between the subject they wanted to teach and the player or the learner. And it felt exactly the same with me with mathematics. So the first and very important design principle in all the games we're making, no words. Eventually it might be a few words, but at the very beginning I don't want to have any words. I want to have a very intuitive experience. You're going to manipulate stuff, you're going to discover yourself how it works, the characteristics of the math concepts. And it's a very difficult constraint, but at the same time, it's a constraint that is, when it works so beautifully. No prerequisite. That means that anyone can play the game you're going to design. And something very, very important, the big ideas of mathematics. I'm not interested in teaching a small chunk or bit of the curriculum. I don't care about the curriculum when I design the games. And it makes people crazy. They say, no, you cannot sell that. And we don't sell that much, that's true. But I think that eventually we will win this battle. The more games that we create, the more likely people are to understand the power of the tools we create, right? So I used to give as an example functions in math. You start with linear function, and then second order functions, and then polynomial function. 1 year later, maybe a little bit of logarithmic function. 1 year later, a little bit of exponential function. And a little bit later, maybe a combination of all of them, and so on. It takes, I don't know, 5-6 years to see the different occurrences of the type of functions, the regular functions that we use. And functions, you know, that's the infinity of functions. So how can you learn what a function is with one occurrence of a function? It's impossible. And still we teach it this way. Right? If I present a dog, you have never seen a dog, and you say, this is a dog. Well, I don't know what a dog is with one occurrence. Maybe I see a cat and I think it's a dog. No, it's a cat. What's the difference? So I insist in my team, I want to teach the big ideas so that kids can really see the patterns. And it has never failed. The power of teaching the big ideas is extremely powerful. It's really, really powerful. Now we're designing a new game, and we cover maybe 5 years in just one game, and in 2 months, I don't know how much time it will take to play it. But it's really big differences. And mathematics is really, actually, not always, but it's pretty consistent. What's not consistent is the language we use to teach it. When we know we have 4 years experience designing that kind of games, I'm amazed by the lack of consistency in the way we teach it and the language we use. Not only we don't use the same symbols across the globe, like the minus sign might be division sign in some countries and minus sign in other countries, and you're thinking, well, what? Right? It's the minus is both an operation, and it's also the sign for negative numbers. How do you distinguish the two? So you have many problems of design or in representation. I'm French, and with numbers, we say 80 for 80. 80, it's 4 by 20. And in English the same, you say 11 instead of 10-1. And the small details like that makes the work to learn stuff very complicated, unnecessarily complicated. 2 hours. Why 2 hours? I don't know. I just say we have to go very quickly to the goal. So 2 hours, that's what we have. That's a constraint. One game, not many activities and so on. I want really an experience with the digital manipulative, the concept, and you're gonna learn through this experience. So it should be one game. And math in the gameplay. And it's very natural because the only thing you do actually in our games is to manipulate math concepts with another representation, but still math concepts with the characteristics that are math. So math should be in the gameplay. So we designed these digital manipulatives, and after a while we see what's the game with this concept. Actually with numbers, for example, what's the game there? Well, actually we discovered a game with kids. It's to create the highest number. This is a fantastic game for kids. They want to go forever towards eternity maybe, or infinity at least. It's beautiful. Yeah, so I'm going through the 3 games we have made or are making, and highlight some learnings. So the first thing is representation. So I mentioned that, problem of language. This is the prototype on paper. All the games are prototyped on paper and tested on paper. It goes much faster. Really, really fast. And some people say, well, no, it takes me no time to develop it. I can program it. No, forget about it. You cannot iterate on that. I take a piece of paper, I cut and so on, I test. In 3 hours, I'm done. I have a first iteration, right? So this problem of representation is really, really key. If you want to learn something faster, I think you have to work with the representations. Not only in mathematics, can be over subjects. A key challenge, now I'm thinking of marketing, not only marketing, but actually disseminating what the value of your work, is that if you change the representation of math, the majority of people will never understand what you're doing. And when I say the majority, is 99.999. So it's a challenge. It's a bit too innovative, maybe. For kids, it doesn't play any role, because they learn math with this representation, and it's math. Once you have understood the concept, the underlying concept, that you change the representation doesn't cause any problem for kids. On the contrary, adults, if you show a new representation for something they know, they are really disturbed. So some people ask me, how did you get the idea of this game? Well, it started with actually a simple challenge. It was to get my son to understand negative numbers, the kind of symmetry you have. And I wanted to show it to him in a very elegant way. And certainly it exists, I don't know. I put a card, and I put a number on one face, and on the other face I put -1. So 1 - 1, 2 - 2. Very simple. It's really logic, actually. And little by little, I cannot explain what happened, but something happened in my brain, and I was thinking, wow, we could do that with everything, and maybe with algebra, we could design this game with cards. Oh yeah, well, let's do it. And then I cut a lot of paper and tested the game. I had no experience really with testing games. I'm not a game designer, right? But I saw my kids, they were getting the rules very quickly. So I was thinking, wow, it's working. And I was thinking, wow, it's working really fast. So then I was thinking, well, let's make a game about that. Right? It was after the brainstorming session I had with my colleagues. What does it take to go from this prototype to this? Well, a year, 10 hours a day, the last month, 20 hours a day. Doesn't seem too complicated, but it was really challenging. So we started with this representation. So I wanted really kids to get a very intuitive way to perceive what equations are with a simple rule or simple game goal. Isolate the unknown, right, for linear equations. And I don't pay attention to the curriculum, right, but I don't pay attention to the formalism of mathematics either. So I can really innovate as I want. So I said, well, one line, so boring. Let's put that in 2 dimensions. And then a colleague of mine said, oh, we should do that in 3 dimensions. So we could do that too. I put the cards, and it was okay. It worked pretty well. And then we were thinking, yeah, but this is equation solving in 2 dimensions with no operators, no signs as usual. We were pretty satisfied by that because it was a real game. When we play tested it, it was working really fantastic. Extremely powerful. So powerful that at the birthday of my son, I was 9 at the time, I put a tablet on the table. Kids were playing poker. So I said, "Oh, can you please playtest this one?" And I said, "Well, okay." And at the end of the birthday, they were not playing poker. They were around the table playing this game in this form together. A social process. It was a fantastic experience for me. But it was not enough, because if I show that either to teachers or parents or whoever, they don't see anything. They don't see its equations. They think, well, nice game, Jean-Baptiste. It's not math. I was thinking deep down inside, but this is math. It's just another representation, but it's equation solving. So we had to scratch our head many times on, wow, shall we go to the normal formalism? We didn't know we could do that actually at the time. So it took us really a lot, not of energy, but a lot of, what would be the word for that? It's counterintuitive for me to go in that direction. I was pretty satisfied with this one. And a lot of efforts, mental efforts, to say where we're going there. And I was thinking, it's going to get boring. So we introduced equal and plus. And it didn't make any difference to kids. So it was just a lot of learning. It was, well, wow, really? The representation doesn't matter to kids once they have understood the concept. And then we were thinking, wow, shall we dare put some letters just to see what's going on? And kids, it doesn't matter. It's the same game. And the beauty, I don't know if you see here. So in the equation, you see a box there. The box at the top left, that's the unknown. And there are some glow or some stars around it. It's kind of a meta concept, right? That's the unknown. And we changed that to the X. And many parents came to us. They had play tested that themselves as adults. And they were complaining. They meant that our design was really, really bad. That we are doing a bad job. It's never going to work. Kids will never understand that the box there and the X is the same object. Many, and they were furious at us. Angry. Pretty weird reaction sometimes. It's never going to work. I will never use that. It's not going to... And kids, how long does it take for them to understand that the box and the X is the same thing? I can't tell you, a millisecond. A question. Where is the box? Oh, it's there. Case closed. So we had the first version of the game. It took a year to do with very simple linear equation. And it took us a year again to do a new game, to make a new game with much more learning. And then we put parentheses, so we found a metaphor of bubbles. We added negative numbers, or you can flip everything, fractions, and you can create your own variable or parameter with this box there. It's extremely powerful. You will need that for integral and so on. And it worked pretty well, but it's a little bit too much maybe. It takes 6 hours to perform the game. So it's not all kids motivated to go to the end. And it's not a problem. I mean, you cannot get all the kids all the time. Even a normal game would not achieve that. So for us, it's a tool. We are making tools, right? So I guess with this first game, we really understood the power of representations, intermediate representations, and how powerful the brain is. As soon as you understand patterns, you can change a few things, but you will still recognize the patterns. Maybe something else I should add on that. As a teacher, I used to spend some time preparing my lessons. And one day, it's more than a day actually, I spent during a week 28 hours to prepare a lesson of 2 hours. 28 hours for 2 hours. No teacher is doing that, right? I was doing that just as an experiment. And I got marginal better results. Only marginal. That kind of game is made by a multidisciplinary team with game designers, art directors, really experts, 28 years of experience. So basically it's 4 or 5 people during a year preparing this lesson. And it's not just a short lesson because there is so much learning, right? So there is kind of, what's going on there? Yeah, that's the right way to do it, I think. New industry, new tools, new productivity. So after algebra, we were wondering which game we should make. It was kind of difficult, actually. And at the end of the day, we picked geometry. And it was a lot of fights in our team. Because we had different goals. If you don't know this book, that's Euclid's Elements. It's a version of Oliver Byrne. I had never actually read Euclid's Elements. This is beautiful. This is a beautiful book. It's a piece of art. Oliver Byrne in the 19th century, late 19th century, he was thinking, well, students, they struggle to read this book. Well, you know, only language, written language, small shapes and so on, no colors, nothing, really, really dry. So he decided to create a new representation for angles and so on. And it's beautiful. And actually you can read that, you can read proof or, you know, propositions, theorems and so on, just like a novel almost. And it's very satisfying because it's very consistent. There are flaws in Euclid's Elements, as you might know, but still you perceive the consistency and the logic behind mathematics. I mean, with that kind of geometry, right? And the fight was, the beauty of this, and what I meant was very important to kids, my kids in particular, when you study mathematics later on, you have really to never forget how you prove stuff. That's the key element. And although I've been to elitistic schools in France and so on, I mean, they do nothing to teach you these basic elements. Nothing, zero. The contrary. So I wanted really to design a game that teach kids proof. Not only proof, I wanted to train the brain of our kids to understand that you can also use creativity when you do proof. And if you are familiar with Euclid's Elements, the beauty is that you have both a construction and proof. Why is that? Of course, if you just draw stuff, you never know if the technique you use is correct. Might be just random chance. So you need to prove all the construction methodologies that you build. And this is key. We were running out of time and money at this time, and we had started with the construction game. And part of my team was saying, well, let's release this game. I say, I will never release this game. Why? Because we had some levels. You could, because of the approximations, you could reach a goal, a point that you wanted to build a point, but it was not really the truth, if truth exists. And it was very obvious that you wanted to get a game about proof, to prove that what you draw is correct, and you have really reached this point. And they were stressed, and they say, we had a lot of back and forth, and it's really demanding to create a game. And say, well, let's release the game. And I say, no, we don't release the game. We don't have any money, but still I want to go towards proof. So we made a game about proof, but without the creativity component. If you remember geometry, sometimes you can draw a segment, and it appears a shape, like a triangle or something like that. And then you can use that to prove other stuff based on the properties of the new shape you have drawn. So we made this game, and if you're interested in marketing, we call that DragonBox Elements, because it was about proof and not geometry. And the majority of people have never heard of elements, so they didn't catch it was about geometry proof. Well, still it's called DragonBox Elements. I like it, but apparently people are a bit confused by that. We changed the representation of, for example, a trapezoid. That's the figure the shape you see there, this guy with 2 wings. We had to find a representation, I will show you that on the iPad, of parallel lines, because remember the constraint is no language. So we had to find a new representation, graphical representation, for all the properties of the shapes. And it worked pretty well, and kids love it, and they see really the consistency and the beauty in proving stuff. This is by far one of the most important thing, I think, game in mathematics that you can get to your kid. And you need to not explain, but ask your kids, after playing this, what are you doing there? Well, I want to find this monster, but I'm missing some information and evidences. And you need to train that, not only for mathematics, but also for writing. When you're gonna, it's a process. You need to argument. You need to build your argumentation, and you need to be trained. And again, here, the time on task is 100%. Everything you do is proof. So different representations and so on, yeah. So after we worked with this geometry proof game, we had still a little bit of money, and actually we made some money and energy, and we were thinking, what do we do now? And we perceived that where is the limit between entertainment and learning? And I do know that some people think that, well, you shouldn't create specific learning games. And I agree, I don't like the expression learning games, and I don't like the fact that we target specific learning. But at the same time, mathematics is, to me at least, just a game. I'm not a game designer, I just take the game of math and I reveal it in a game. So I just work with the representations, right? So, but still I was wondering, is there really a limit between entertainment and that kind of learning? And not only my intuition, but the playtest tend to prove that actually there is no limit. There is no limit, especially for younger age. Everything is just play and games. And if you take math, it's just another game. And it's very consistent. Therefore, an even better game. So these days we're working with numbers. We are trying to, we have a very ambitious goal, to cover the full primary school mathematics curriculum with 3 games. Other ways, we test things with prototypes on paper, different mechanism, and to get a sense of what the game is. And after a while, we end up with new representations, new environment. This is number 1, number 2, number 3, number 4. All of them are characters. They have their own personalities, and they have properties that are math properties, actually, and kids just enjoy it. Maybe what I want to mention there, to get the entertainment value, it's not only because of the graphics. Of course, the game mechanics is extremely important, the social components are important, but still the fact that you can get this graphic value, the fact that it's appealing, it's important, and it has a huge value, I think, to kids. And then I see that there are actually no boundaries between entertainment and learning. It's the same for kids, really. And in the playtest, kids can play that forever. I've talked mainly about games, But games is nothing, it's just a resource, right? And as a teacher and educator, you cannot stop there. What you're interested in is the learning experience, not only the design of games. You're interested in the full ecosystem. What's going on? How can your resources be used? What kind of use cases you have? And actually, what we are doing now is putting a lot of energy on how can we design the learning experience, not only the game. So the social context is extremely important. This is a picture from Norway where we organized a big competition. Some 40 or 50,000 kids were registered, maybe 40,000 played during a week. Class against class, highest number of equations solved per student. You would win an iPad if your class wins. Kids were playing at night. 40% of the time was played outside the school time. A beautiful experience. Bigger scale, right? A little anecdote. So the competition would be opened by the Prime Minister in Norway, where I'm based. And at 8 o'clock I received, 8:15 or something like that, I received a call from a colleague. Hello, Jean-Baptiste. I think we have a problem. Many teachers are complaining. The servers crashed. I mean, you work at Google, so you know what it means. Something that we had not foreseen is the fact that many teachers wanted to participate in that because it's so boring, the normal school days. And all of them had planned to start playing at 8:00. Beautiful anecdote. I guess I lost 2 years of my life stressing like hell because the Prime Minister would come and open the ceremony. We were in a classroom and kids were there. I cannot connect. And I was just journalist, TV, press, everyone was there. And it was really a nightmare. And we did this project with the University of Washington, with Ran Popovich, Center for Game Science. 9 hours difference. So for them during the night, it was really a nightmare. But they did a fantastic job. We just lost 15,000 kids. And I guess the confidence and trust from thousands of teachers. They will never come back to us, I guess. I don't know. And why do I say that? Innovation is about experimenting. It's about failures as well. And that's the learning process. You cannot avoid it. You can think a lot, hard. You're going to fail sometimes. And what I perceive as very difficult in the school system, generally speaking, is that you're not allowed to fail many times, right? So how to create a culture for testing new stuff at larger scale? Because sometimes a pilot is okay. Usually pilots, they work. But it's when you have the bigger scale that things are really getting exciting and where you discover new things. So that was the Algebra Challenge. That's the name of the event. We have run that in a couple of states in the US. We had that in Norway. We're going to have that in Uruguay soon. Data, yeah. So imagine you are a teacher. You are teaching as usual. You have prepared your lesson for 1 to 2 hours, maybe less, giving your lesson. And when it's finished, it's finished. You don't know what happened. You don't know how kids have learned. You don't know what they learned. You're gonna know that when we're gonna give a test. And the kids will know if they have learned 2 weeks after the test has been given. So you have cycles of something like a month or a month and a half before we know what's going on. Usually with the game of school, we know already what's going on. Actually, it's not necessary to play this game. The good students are still the good students. Some accidents sometimes. And the students who have lost their self-confidence, maybe self-esteem. They are losers. They accept that. And every month and a half, they have a confirmation that they are losers. It's a beautiful game. Not many data. We know everything already. But with the kind of tools we have with these video games, we have the opportunity to collect data about what kids are doing. And we can improve the algorithm to serve adaptive levels to them. So it's kind of big data trend in education. Not based on quiz and assessment, based on the learning process. Where are they? What are they struggling with? Which concept is difficult? Which strategy are they using to solve that type of equation or that type of geometry proof problem? It's a completely new world. And it's not accessible unless you have very good game mechanics and good games. And it's not that many of them. So I put that here because creativity is not only in mathematics, it's also in editorial teams. It only takes about 42 minutes to learn algebra with video games. What a beautiful title. You can't imagine the amount of hate it generated. Wow, this game, boo! No, I didn't write this article, I'm sorry. The only thing I'm doing is, I'm doing a pretty good job at designing games and learning experiences, and we're collecting data, and I'm sorry if the guy found this title. Well, the beauty, okay, generated a fair amount of hate, really. We had many people who got awareness about what we're doing, and some people were thinking, well, that's a good thing, I want to try that, which is good. But of course, we have to take some perspective and some distance with what we get, with the data we're getting. Really, after 1.5 hours, kids are mastering, 93% of the kids, after having played 1.5 hours, are mastering the rules of algebra in the game. There is some help in the game, but it's mathematic gameplay, as I would call that. So that means that they are really learning. So it's very efficient. And the data we're collecting are really, really, really interesting to understand the learning process. And it's real learning. Although it's not transferred to pencil and paper, we can do that later. And we have made many stuff to be able to ease this process. Yeah, that's what I want to say. We are humble and we are really into learning. We are not interested in that kind of titles or headlines. Although it gives some publicity. These are some of the statistics we got from the different challenges we have performed. And I want to attract your attention to the 2 lines here, 10 times faster and 7 more content. 10 times faster. That's the difference between the slowest learners and the fastest learners in decile. 10 times. So if you, as a teacher, you know that there are big differences between kids. But no, we can measure that with adaptive levels, with math in the game mechanics, time on task, and so on. 10 times. If you think of that, you say, why are these kids in the same class? Well, it doesn't work like that. I mean, there is a problem, fundamental problem there. And not only that, we know the number of exercises we had to give to kids. And between the slowest and the fastest, 7 more content. 7 more content we have to deliver to the slowest kids. So we can put a number on this. And it's not 1, it's not 0.5 or 7 and 10 times. It's really big numbers. What do we do with that? How can you engage and motivate a kid to work 10 times more than another one? How can you do that? How can school do that? How can a teacher do that? It's impossible. Mission impossible. But we still keep on doing that. Teachers all over the planet are doing that. 30 kids, and they're trying to say, well, no, we're going to learn that all together. A nice day. So what's next for us? So we're experimenting with these learning experiences. We are working on new gameplays or new games. And there are many, many, many things we can explore. We are a very tiny team, I don't know, 13 people. But we see many research areas. Like, for example, now in many countries in South America, they have a one-to-one with the same tablets. What can you do if the whole country, each kid has a tablet? What kind of interaction you can make? What kind of learning experience you can generate there? It's fascinating, the number of possibilities we have there. And I think we're going to spend time exploring this. Really, how can we create a game experience there with this hardware? Much more to do with higher math, so many areas of exploration.
Thank you for the talk. It was really excellent. I have a question, which is, do you feel that the game is sufficient in itself for learning to happen, or do you think it's best used as a tool in the hands of teachers to map the concepts, the mathematical concepts, to other real world or whatnot?
So if you are parents, I would play this game with my kids. I wouldn't let them play alone, actually. I would play it with them, just like you help them learn to bike, and you're very glad when they bike. I would play this game, either geometry proof or algebra, and explain more how to transfer that. In the algebra game, it's really about the manipulation, the algebraic manipulation. It's not enough. We don't say why it works like that. So there is no link today to arithmetic. I mean, why? So it must be complemented by either a teacher or a parent. At the moment, it's like that.
You said you were working on some things to help with the transfer from the game to pencil and paper. Can you describe what those are?
Yeah, in the game you manipulate cards, right? And there is a help mode. We help we really help kids really get a fluidity in doing things. So we are helping them a lot in the interaction design. But there is one step where we don't help them at all. So there are no help. And then there is the handwriting recognition. So we can go towards the full stuff there. And just what I've mentioned, get not a new game, but a kind of an experience where they can link the algebraic rules with what it means with numbers. So that they connect the two. So that's very important to connect arithmetic and algebra. And then you have the full package. Yeah. So it's possible to do it.
So first of all, thank you. I love these games. My daughter does too. One thing I noticed is that my wife loved math until she got to trigonometry,
yeah,
and then kind of gave up on it. And I got her playing the game, and she couldn't put it down until she stayed up till like 1 a.m. to finish the game.
I'm sorry.
And no, it's a great thing. And so I'm wondering if you guys are looking at adult education. I mean, that seems to be a huge growing market as well. And I totally understand your point too about how you show this to adults and they say, oh, this isn't math, I don't know what this is. Because that's what algebra, which she loves. When I showed her that one, she had that reaction. But trigonometry, which she, and geometry, which she doesn't love or understand, she could play it like a game. Mm-hmm. So I'm wondering, are you guys thinking about approaching the adult education market and breaking through those barriers and things like that?
Yeah, definitely. We're gonna do that. But when we designed the game, actually, the first game about algebra, it was meant for kids around 12, and because of the constraints we had made, no language, and it must be like a game. And unfortunately, or fortunately, I don't know, one of the Wired GeekDad journalists wrote an article saying, it's incredible! My 5 and 7 years old girls are playing algebra. And since then, who are our customers? What do you think? Parents with head start in their head and are thinking, yes, algebra to my kids. My point is that we're going to target higher math, but always with the same constraints. And in math, the beauty is that it can be very visual if you have the right design of the interface. But definitely statistics, functions, even calculus or trigonometry can be made. I mean, I'm pretty confident we can do that. But we have limited resources, so maybe there are other people who can do that too. I promised my son to be finished with the high school curriculum before he leaves school, and it will not happen unless other people are joining the mission. So I encourage you to do that. Yeah.